Welcome to review of logarithmic functions. First, we're going to have a look through our log laws. So a reminder that if we have y equals log base e to the x, that means that we can transfer that to x equals base e to the power of y. Second law is that when you add logs with the same base, then you multiply. When you subtract logs with the same base, you divide. Log of any base to itself is equal to 1. And log base a of m to the power, you can then bring the power out the front. Now, these will become important when we do some of our applications a little bit later on. So just remembering these laws. And the final one is change a base so that if we want to be able to use our calculator, if I have log base a of b, I can change it to log base 10 of the b, so the top number, over log base 10 of a, so the bottom number. And that's important when we want to perhaps calculate or work out a particular value. Just a reminder that log base e of x is the same as ln x. So on your calculator, you'll see it as an ln button, which means log base e of x. Little things to keep in mind is that logs and exponentials are opposite, so the inverse of each other, or they undo each other. So log base e to the power of x, so because it's log base e to the e, that in a sense cancels and we're left with the x. Or you could bring the x out the front and we know the log base EV is 1. One of the ones that sometimes gets a bit confusing is that e to the power of ln x, an e and an ln cancel and we're just left with what's after the ln. So this might be maybe applicable as we go through and do some questions. We're about to have a look at the curve, y equals log ex. It's always concave down, so remember it's the opposite of an exponential. So log curve is always concave down, so it's always pointing downwards. And it is increasing, so it does go up, but the rate it increases is actually slowing down. So it's increasing at a decreasing rate. And let's have a look at our graph. So you can see that it's concave down. It's always pointing downwards. But the curve, as the x values get larger, so as our x values increase, the rate or the steepness decreases. So it's increasing at a decreasing rate. The log approaches the y-axis, that's our asymptote, but doesn't actually touch it, passes through 1 on the x-axis. So now we're going to have a look at shifting some of our curves. So one of the little things that we did before. So we're applying some of those rules. So log e of minus x. So remember, if it hits the minus on the x, that rotates it across the y-axis. If we affect the function, so in the second example, so if we minus the 3, we move it up or down. So in this case, minus 3 is going to move the whole graph down 3. And the last one, if we affect the x, that shifts left or right. So x plus 2 is going to shift it 2 to the left. So minus 2. So here's our first one. So minus x. So the effect is on the minus x, flips the graph across the y-axis. So the asymptote is still the y-axis. The next one moves the graph down 3. So it originally passed through at 1, 0, 1, 0. It now passes through. If we move that down 3, the new point is 1 minus 3. So the blue one is the new graph. We've just moved everything down 3. So it still approaches the y-axis as our asymptote. And we can find where it cuts the x-axis if we let y equal to 0 and solve. And the answer ends up being e to the 3. And the final one, if we move it 2 to the left. So the x plus 2, the effects on the x, moves it left or right on the axis. In this case, it's moving it 2 to the left. Okay, so it goes from currently cutting at 1, 0 to moving it 2 to the left, meaning it now cuts at -1, 0. Our asymptote used to be the y-axis, but if I move that 2 to the left, my asymptote now becomes x equals -2. Is that my new asymptote? All right, let's have a look at some of our using some of our rules. So, log base e of e to the 2, log of e, 1 over e, and e to the ln of 10. So these are our new rules that we sort of looked at. So we know that log base e of e cancels each other out, or we could have brought the 2 out the front, and log base e of e is just 1, so we get 2 for that. With the second one, 1 over e, we change the 1 over e to the -1, and then using the same as in part A, that's equal to -1. And the final one, e and the ln cancel each other out, so they're opposites or inverse functions of each other, and we're just left with the 10. Now we're going to have a look at solving using exponentials and logs. We're using the exponentials because it will solve to end up being logs as well. So the first one, ln x, so remember that's log base e of x minus 16 over ln x equals 0. So step 1, we're going to multiply everything by ln x. And you can see that when we times everything by ln x, we get ln x all squared minus 16. If I take the 16 across, I get ln x all squared equals 16. Take the plus or minus square root of 16, which means that my answers can be 4 or minus 4. And then using our rule before, log base e of x, if I want to leave the x by itself, I take the e and make it the base on the other side. So x is equal to base e to the 4 or base e to the -4. And they're exact solutions, so we'll leave them like that rather than do decimals. Final one. So this is a little bit trickier. So 4 to the x, so 4 is 2 squared, which means that I can actually write that as 2 to the x all squared, that first term. Minus 7 times 2 to the x minus 8 equals 0. So I'm going to, rather than solve it like that and try and get you to recognise that that's a quadratic, we're going to just replace the 2 to the x with the letter u. You can use any letter you want, but let's use the letter u. So the first term becomes u squared, then we get minus 7u minus 8 equals 0. And what they do is they will always form a quadratic that you'll be able to solve. So factorising that, you get u minus 8u plus 1 equals 0. So solving for u, we get u equals 8 or minus 1. So that's fine, that gets us our u value, but u was equal to 2 to the x. So 2 to the x is equal to 8 or minus 1. But an exponential can never equal a negative. So 2 to the x equaling minus 1 is not a solution. So the only solution is 2 to the x equals 8. And so x equals 3. 2 cubed is 8. I could have also done that as logs. I could have made it x equals log base 2 to the 8 and then gone and done change of base and would have got x equaled 3. Thank you.